Today we'll be doing section 4.3, the first derivative test for local extrema. And before we really get into the video, I just want to remind you that at any point you can pause the video to write down notes that will be important. Alright, and before we get started, also remind you that when f of x is increasing, f prime of x is positive. And also that when f of x is decreasing, f prime of x is negative. And when f of x is not changing, f prime of x is 0. These are important things to remember for today's lesson. Now we'll look at a figure that is from page 205 in your book, and it's figure 4.18. And it's a really good visual representation of what today's lesson will be. So when we're looking for local or absolute extrema, we always want to look on our endpoints, which are very important to look at. When f prime is equal to 0, which will be at these points, and where f prime is undefined, which is here. These are really important values to look at. So here we have f prime equal to 0, f prime equal to 0, f prime equal to 0, and f prime equal to 0. And here are endpoints. So just by looking at the graph, you can tell that these are absolute minimum. Also with this one. All the examples we do today will not be in a closed interval, so we might not have any absolute extrema, but on this one, since it is closed, we will. So this brings up a very good point. We need to look for critical points, critical values, where f prime is 0, where f prime is undefined, and at endpoints. It's very important that we don't forget to look at all these different points. Otherwise, we might forget to find one of them. Now, how do we figure out if these points are maxes or mins, or if they're not anything at all? So what we do is we want to look at values on either side of them. So we're just going to draw these in real quick. It'll make it real easy to look at. Now what we want to do is we want to look at how f prime is behaving in between these. So here, f prime is greater than 0. Also, f prime is greater than 0 here. Here, f prime is less than 0. F prime greater than 0 here, f prime less than 0 here, and f prime less than 0 here. Now if you're wondering how we figured this out, you just look. When the function is increasing, f prime will be greater than 0, increasing, greater than 0, decreasing, less than 0, and so on. So now this will help us determine whether these points are in fact absolute or local extrema. So at this point, we have an increasing and an increasing. So we have no sign change. So there is no extrema here. Here we have positive, increasing, and then negative, less than 0. So we have a local max. Here we also have a sign change. We have less than 0, greater than 0. So we have local min. Here we have greater than 0, then less than 0, so we have a local max. Here we have less than 0, so no extrema. So this graph really does a great job of showing all the different possibilities of what you can have. We have minimums at endpoints, which was one of our places to check. We have it where f prime is 0, we have a max, a min, and then we have where it's undefined. It's undefined at this point, but we do have a sign change, so it is a maxima. But it also reminds us that we have to be careful, because just because f prime is 0, that doesn't mean we have an extrema. You have to have a sign change. This is very important, a very common mistake. So, when we get into the lesson, we'll see how we determine if there is a sign change so we can see whether we have local extrema. Now, this would be a great time to pause your video and either copy down this chart, this graph here, or you could refer to your book. But this is a really good one to have in your notes for reference. This is the graph that we just worked through. And now here you can see the chart that starts on page 205 named First Derivative Test for Local Extrema and continues over onto page 206. I would really take the time to look in your book right now and copy down this chart before we go into an example. It's really important that you have this chart in there. Now we're going to work through an example. Now I'd really encourage you to put this in your notes so you have something to reference back to as we work through it on here. Alright, so let's say we have the function f of x equals x cubed plus 3/2 x squared minus 18x plus 5. So this is the function that we are going to try to determine where our maxes and mins are. Now, since this isn't on a closed interval, we probably don't need to look at endpoints because we all know what the x cubed graph looks like, and the lines go in either direction forever. So we're not going to have to look at endpoints. Now, once we have this, we're going to use the first derivative to determine where our extrema are at. So first we need to find the first derivative. So f prime of x equals 3x squared plus 3x minus 18. So that is our first derivative. Now, the first step that we need to do is we need to factor this out to find the zeros. Now, I rigged this one so we are able to factor it. If it's one that can't be factored, you can just plug it in your calculator and use the trace option. So we want to set these equal to 0 so we find where the derivative equals 0. So we have the derivative equaling 0 at x equals 3 and x equals 2. And like I said, if you can't factor it, just plug it in your calculator. You'll be able to get the zeros. Now we also have to remember, we already talked about the endpoints. So endpoints, we looked at them and we don't have any in this one, so we don't need to worry about that. Our zeros, we're going to deal with these in just a second. We do have our zeros, we did find them, now we just have to apply them, and undefined. And also, if we think about a graph that is squared, it is really nice and smooth and easy, and we don't have any undefined, so we also don't need to worry about undefined. Alright, now once we have our zeros, we're going to set up a number line, and this is when the first derivative test starts to come into play. So we're going to set up a number line. Since we're not bounded, we're going to have arrows on the end, and we want to plot our values, -3 and 2. And like we showed in the graph, what we're going to do now is determine how f prime of x is behaving so we can see if these are, in fact, local extrema. So what we want to do is we want to plug in values on either side of these numbers. It doesn't matter what the value is. It could be way far negative or -3.5. I'm just going to choose -4. So we want to plug this value in to the derivative. It's very important that we plug values into f prime of x. It's very important. So I said we'd use -4, so 3 times -4 squared plus 3 times 4 minus 18. Now it really doesn't matter what this value turns out to be, it just matters that this value is positive. So we're going to put nice plus on our number line, so we know that. And then now we need to find one in between these, and a nice value would be 0. So 3 times 0 squared plus 3 times 0 minus 18, so we get negative. Remember, it only matters what the sign of these values are. So we have negative, and then we need to pick one over here, so we could just go ahead and use 3. So 3 times 3 squared plus 3 times 3 minus 18, it turns out to be positive. So we're going to plot that. So we do have sign changes, so we will have extrema. So now we want to think about this. At -3, we have increasing and then decreasing because we have positive and then negative derivatives, so that would give us an increasing and decreasing function. So this would be a local max. And now what we need to do is figure out what the coordinate for the original function is. And since we're talking about the original function, we're going to use f of x, not f prime of x, because we want the coordinate for the original function. So we would do -3 cubed plus 3 halves, -3 squared minus 18, -3 plus 5. We need f of x because we want the y value for the original. And this gives us 55.5. So this is our y value. So we have a local max at -3, 55.5. This is our coordinate for our original function. Now we need to deal with 2. At 2, we have decreasing and increasing because we have negative and positive derivative. So this is a local min. Now, like the one before, we need to plug these values into our original function since we want the coordinate for the original function. So we're going to have f of x equals 2 cubed plus 3 halves, 2 squared minus 18 times 2 plus 5. And this value turns out to be -7. So we have a local min at 2, -7. So that is how you do the first derivative test to find local extrema. Now I just want to make sure that you really understand the procedure, what we did last. So we had an original function, f of x. Doesn't matter what it is. It's always going to be the same procedure for every problem we do. So first what you want to do is you want to find f prime of x. And then you want to find where f prime of x equals 0 and where f prime of x is undefined. And also, don't forget to look at endpoints. So that's the first thing you want to do for determining the values. And once we have it equal to 0, remember we want to set up our number line, whether it's on an open interval or a closed interval, and plot our points wherever they may be. And then we have to check values on either side of our points. We want to make sure that we check all of them. No matter if we have 2 or 4 or 6, you have to check every single value to make sure that there's a sign change. So if we have a positive, then a negative, we'll have a max. If we have a negative, then a positive, we'll have a min. And if we have no sign change, we won't have a local extrema. So no mins and no maxes. It's really important to remember. So once we've determined the points and whether they're a min or a max, we want to make sure that we find the coordinate. And remember, we plug these values into f prime of x. It's very important that these values get plugged into f prime of x, all of them. But then when we go over, once we have established the x value, so we have an x value, now we want the y value. So when we want the y value, we have to plug it into f of x, the original function, because now we want to find the coordinate. So we're just going to plug the x value into f of x, and this will give us our x, y coordinate for the min or max. So that's just kind of a summary of what we did in the previous example. Now that we've done an example, you should try this for yourself. So in the book, on page 206, try example 1A and B. The book also provides good explanations for the answers, so right now, pause your video and work through these examples in your notes. Now, I told you always to check for the extremas at when f prime equals 0, when f prime is undefined, and at endpoints. And although the table in the book touches on it, I just want to make sure that you're able to find the extrema at endpoints. So let's say we're working from the left side of the graph. So if we have a big long graph, this is the end of it. So our point is here. We want to see if this point is a max or a min. So if our graph goes like this, and we have, that would mean that f prime is less than 0 because we're decreasing. That would mean this is a max. So that's how we do it for that endpoint. And then if we're still on the left side of the graph, this is the end of our graph, and it goes, this is our point, and it goes up this way, this means that f prime is greater than 0, so this would be a min. This is for the left side of the graph. And like I said, this is in the book, but I just want to make sure that we touch on it because it may come up in some of your problems. And then if we're having the right side of the graph, the graph ending over here and our values here, if we're coming in like this, then f prime would be less than 0, but this would be a minimum, opposite of what we had here. And then, so opposite as well, okay, this is the edge of our graph and this was our point. We are coming in like this, f prime will be greater than 0, which would give us the maximum. And really, don't get too caught up on this. All you need to do is look at the graph. You should be able to determine just by looking at it if it's a max or a min for the endpoint ones. Just make sure that you know how they are found. And for the extrema, you just need to look for sign changes. Same with the 0. So an f prime is undefined. You need to make sure, let's say f prime is undefined at 3 and f prime equals 0 at x equals -5 and 7. So if this is our number line, we need to make sure not only do we plot our zeros, -5 and 7, but that we also plot our undefined value at 3, because we need to check the sign on either side of also the undefined, not just the 0. So when you're working through this problem, just don't forget to look for the f prime undefined and make sure that goes on your number line also. I know the example we did didn't have any like that, so don't forget. Now I think you're ready to do a little more practice on your own. So I'm suggesting that you would do on page 215 exercises 1 through 5. Odd. That way all the answers will be in the back of the book if you need to refer to them. And remember, this is a video that you can rewind, so if you want to go back and look over the example again, feel free to, and you should have some really good notes on what you should be doing, so just look in your notes, look in your book, and I think you'll be able to complete these problems.